In the beginning, the world was dark because there's no blockchain. But in 2008, Bitcoin came along. It's a 0 to 1 technology, meaning before Bitcoin, we really had nothing that could do what a blockchain could do. And after Bitcoin, we had pretty much everything we needed. We had a decentralized digital money system with a fixed monetary supply. We have programmable money, a publicly available permissionless database to store everything you need. It was still a little bit dark. It took a few years for it to become popular. But 3 or 4 years later, we see the emergence of the first altcoins. Bitcoin's an open source technology, so people realize, well, we can copy that and start playing around a little bit with the consensus mechanism. So you have things like Litecoin that had a different type of proof of work, and you had Ripple with a managed consortium of banks. But really, they were similar to Bitcoin under the hood, the way the transaction and blockchain structure worked. Fast forward another 4 years, and we see an exponential increase in these altcoins. You have things like Ethereum that had a very different structure, an account-based model with smart contract capability. Cardano, one of the first proof-of-stake blockchains. And the rise of dedicated privacy coins like Monero and Zcash. Fast forward another 4 years, 2020. There's now too many blockchains for me to put on this slide. Now, 2024, there's over 1,000 blockchains. There's over 1,000 blockchains. So what do we do about that? When I explain this to people outside my industry, honestly, I feel a little bit embarrassed. You know, I can think of some archetypal blockchains like Bitcoin and Ethereum, but then I think a lot of these are derivatives, and I wonder who they're serving. But why is this a problem? Well, I can tell you how this impacted me. So, a couple of months ago, I got married. Thank you. The happiest day of my life, my beautiful bride. But the interesting thing here is not that I got married, it's where I got married. It's this place. Does anyone know where this is? Plymouth. Now, I get the nautical reference. No. Spain? Okay, no, but the same language. Argentina. This is the emblem of the city of Buenos Aires in Argentina. My wife is from Argentina. It's a fantastic country. You got to go. Great people, great culture and food. I'm going to cook you an asado. But it has economic problems. It's a really difficult place to do business. They have hyperinflation. So March, the month we got married, there was 11% inflation that month alone. Over the last 12 months, nearly 300% inflation. As a result, they have currency controls, and banks in the UK just will not send money to Argentina. Third-party providers like TransferWise don't operate there. And I don't know if you're aware, but weddings are expensive. We both live and work in the UK, so what do? It turned out that a lot of our vendors would accept crypto. So in particular, USDC. It's a dollar-backed stablecoin issued by, I think, Coinbase on the Ethereum blockchain. So we start paying our vendors for the wedding. So far, so good. Until one day, a vendor calls me up and says, we didn't receive the payment. So I double-checked. Yeah, I send it. Contacted them again. They said, no, it's not with us. Cue a lot of panic. I looked a little bit further, and it turned out I didn't send them USDC. I sent them USDBC. This is a different dollar-backed stablecoin, also issued by Coinbase. What I'd done is I selected the wrong drop-down menu, bought the wrong asset, and sent it to an account that didn't exist. Cue a lot of panic. Luckily, I could convince the vendor that, look, honestly, I'm an expert in the field. Please just, if you extract your private key and send it to me, I'm going to create a wallet on a new platform to get my own money to send back to myself. And this was over $1,000, so this was a lot of money to me. Luckily, I managed to do all of that in the end, but not without a very good deal of pain, goodwill from the vendor. Although I got the payment back, I still spent a lot in fees. So why did this happen? Perhaps the UX of the app was badly designed with this drop-down, or perhaps I was just too busy that day and I wasn't paying enough attention, or perhaps USD-BC shouldn't exist in the first place. Why is it there? I didn't want it. It didn't serve me, but I accidentally bought it. This is my use case, cross-border payments. But let me explain why this is relevant to all of us. So we're trying to build together Web3, a future version of the internet. So Web3, what is Web3? What is Web3? Does anyone want to give me their definition? IPv6, yes, okay. That could be a very important part. Web 2++, okay. I bet I could ask 100 of you for their definition, and we'd probably all get a different answer. Here's the definition, well, the concept I really like. This is not me, this is Gavin Woods, co-founder of Ethereum back in 2014, who summed it up very well. A decentralized online ecosystem based on blockchain. This doesn't mean a wallet where I can trade 1,000 different cryptocurrencies. When I see people saying this is a Web3 app because of that, I think you've got it completely wrong. Whilst we don't have a rigorous definition of Web3 right now, I realize that when we talk about Web3, what we're doing is really signaling a set of values we believe in. Security, data ownership, direct exchange of value. These are very human-centric concepts. And that's something I think we can all believe in when we're trying to build Web3. But the key point is that it relies on blockchain. And at the moment, we have over 1,000 blockchains. So it's a problem we all have to face. So what's the current way of doing things? You have to use these things called bridges. A bridge, like the analogy, if I have one blockchain and I want to move my asset to another blockchain, I introduce a bridge. I have to move my asset onto the bridge and then off the bridge to the new blockchain. These bridges can be either centralized or decentralized model. They can be blockchains in their own right. But to me, solving the problem of having two blockchains by introducing a third blockchain is not a solution. So I don't like bridges. I started looking into how they work, and I keep reading the same things. Locking my assets, swapping my assets, burning my assets. Any system that relies on a third party burning my asset, I think there's something fundamentally wrong with that. And you should be very worried when you hear these types of words being used. What it really means is complexity. They're extremely complex, these bridges. High costs, a lot of pain to integrate, and they only work between blockchain pairs. The biggest hacks in crypto history have occurred on bridges. 320 million US dollars in Wormhole. I think 97 million, I think, on Polkadot. I would steer clear of them. There is a word that I do like. The word I like is transfer. I don't want to have the same value of asset on each chain to swap. It's just I have an asset, a digital asset, that I want to send to a receiver on another blockchain. I just want to transfer it. This is what I want to see. So, with our Web3 values in mind, we at nChain demanded better, and I'm very pleased to announce a world first. We issued an asset to my colleague Josie, who uses BSV. Josie transferred that asset, to John, who uses Ethereum. John transferred that asset to Arthur, who uses BTC. When Josie transferred to John, there was no other party involved. No notary, no bridge, just them. Nevertheless, it was completely secure from double spend protection. The same with John and Arthur. We're very proud of this. We're calling it Universal Blockchain Asset. A token you can issue on one blockchain, but not be restricted to that blockchain. The users can transfer it to recipients on other blockchains and them on other blockchains beyond that. So, how did we do this? We thought, what do all blockchains have in common? What are the properties that we can use on any blockchain? The first is an immutable database. This is the blockchain itself. So somewhere I can record data that won't be changed in the future, that is available to all the users, and this is where you record your transactions. The second property is some form of double spend protection. So in Bitcoin, this would be your UTXO model. In Ethereum, it would be something like an account-based model. But they all have double spend protection. And this really means establishing a sense of uniqueness in a digital world. That's a remarkable property that only blockchain has, and why it's critical for Web3. So just using these two properties, this is what we did. We introduced a new medium of transfer we call a packet. We're being very careful not to use the word transaction, because this is not a blockchain transaction. It's a packet that records a transfer of ownership. This packet on the right here has a list of inputs and outputs. In the input, I have a reference to the previous owner, and I have a signature, well, the previous packet, and a signature from the previous owner authorizing the transfer. In the outputs, this is where things get really interesting. We have the public key of the recipient, but crucially, we have a reference to an unspent blockchain output. And we also specify the chain that lives on. So here, a packet is being sent to a recipient on the BSV blockchain. The fact that the recipient has a nominated unspent output that can't be changed because of the signature means that when the recipient transfers their token onwards, they confirm that transfer by creating a transaction, spending that out point, and updating the NFT or other token to its final state. This is where the double spend protection comes from. It's simple. It's remarkably simple. I can tell you that having done research in blockchain for 6 years and then in academia and math for 10 years before that, the simplest ideas are the hardest. The ones that were staring at you in the face all along. It's also why I know it works. I know it's secure. As long as you understand how this protocol uses blockchain outputs, you've understood everything. And everyone in this room can understand this and verify it themselves. Okay, let's see this in action. So this is a demo of a working implementation. it's actually an NFT of the space shuttle image that you can see here on the right. So Alice is the first recipient of this NFT, so it's issued to her. Alice works on the BSV blockchain, so she selects BSV to receive the asset. She creates her blockchain outpoint on BSV, and now the issuer can assign her as the owner of the NFT. And here you see the packet. Okay, now Alice would like to send it to Bob. So Bob uses Ethereum. He doesn't ever touch BSV. He doesn't want to. He creates an outpoint on Ethereum. An outpoint on Ethereum. That's another story, because Ethereum's an account-based model. It doesn't naturally have outpoints, but we could just code up a very simple smart contract that mimics the properties of an outpoint. So you can use this smart contract to create an outpoint. Then he has everything he needs to receive the NFT. Alice creates the packet, transferring ownership to Bob on Ethereum with his Ethereum outpoint. It's as simple as that. But I'm not going to go into any more technical details than this here, although I would really love to. I'm going to leave you with this, an academic paper you can download right now. You can follow the QR code to our website, download it, read it. This is what we love to do at nChain R&D. We don't just want to talk about cool ideas. We want to go through the rigorous details to prove it's secure mathematically, to prove it's private, to implement a proof of concept that I just talked you through now, paying attention to the implementation details. Please read this. Please verify everything we've done. You'll see examples of packets. You'll see examples of blockchain transactions that you can go through and check how it all works. We're really proud of our protocol, but whilst we've created it, you don't need us to implement it. You can go away right now and start using this. Think how this could integrate with your platform. Think how you could create tokens that can be transferred to any blockchain. Or private ledger. By the way, this is not restricted to a blockchain. Anything that has some form of double spend protection. So, what if your blockchain is different to mine? Now, using this protocol, it doesn't matter. I can transfer tokens across chain just as easily as if I transferred tokens on the same chain. It would have helped me pay for my wedding. It wouldn't exactly have solved my problem, but that problem would not have existed in the first place. There's no concept of being restricted to one blockchain when I issue, for example, a USD stablecoin. So perhaps you're a central banker or someone who wants to issue a CBDC or stablecoin. You now no longer need to be locked into one blockchain. You can deploy on one, your favorite one, and allow your customers to use any. Less cost, less risk, a much wider market. That's just a CBDC cross-border use case, but imagine others. Ticketing for events. Think of all the users. It doesn't matter what blockchain they're on. Think of GovTech, cross-border payments, healthcare. I could be issued a prescription on one sovereign network and redeem it at a pharmacy in another sovereign network. Gaming. You name it. So, I invite you to join me in this future because we can interact together because it doesn't matter what blockchain you're using. I really want to hear how you would use this. How would it benefit you? How would it benefit your business or your customers? I'm here for the whole conference. I'd love for you to talk to me. Tell me what you think about it. Tell me how you would use it. Thank you. Yes, and we have time for questions.
This is the funniest little box. I love this. It's hilarious. Okay, so I am kind of rebranding myself at the moment, post-BSV apocalypse, or whatever we want to call that. And I looked at an old video from 2018, December 2018, when I held a conference in Miami, and I keynoted with Jeremy Gardner and Brock Pierce, and I created the first Miami Blockchain Week. And in that video, it's so interesting to look at it all these years later, I'm like, yeah, I really need to lose weight. But more importantly, we were having the same conversation in December of 2018. We were talking about interoperability, why one chain doesn't talk to the other chain, and dApps don't, right? So I think that this is brilliant. I guess my question is it going to be, would we have to license it through nChain, or how would we get access to this?
I think, yes, it's proprietary technology from nChain.
Yeah.
But the important thing is you're free to use it right now. You don't need us to help build it. Right.
Okay. Interesting. Thank you so much, Owen. That was amazing. Anybody else?
Oh, sorry. Right here.
Yeah, thanks for that. If I have passed the token across to you and you've passed the token across to Robin, and then Robin passes a token across to me on my chain,
yes,
are the two tokens, the original one and the new derivative one on the same chain, are they fungible?
Could you repeat the question? If I understood correctly, it was the same token being passed around?
Yeah.
It is, but now it's moved around in a loop, and it's come back to the same chain.
Yes, it's the same token. It has its own unique history since issuance. It doesn't matter that it's come to the same chain. Maybe it's a token that it predominantly is transferred on the same chain, and then only every now and again goes across chain. The point is, it's as easy to transfer on the same chain as a cross chain. It's not restricted to be only a cross chain transfer protocol.
Right.
You can transfer on the same chain. And if you just want to use it on BSV, just use it on BSV. Yep.
Thank you. Thank you.
Question?
Hello.
Hi.
I would like to know how it is different from the Cosmos network, because it also provides the interoperability between the blockchain networks.
Yes. So it's Cosmos is a bridge. So the difference is, if I want to use Cosmos, you can use that to move assets, I would say, to different chains, but it's introducing another actor or another platform into the game. I have to have an account with Cosmos. I have to rely on the security of Cosmos not being hacked. In this scenario, there's no other party involved other than the two transacting parties, Alice and Bob, and there's no other platform involved. So we're achieving the same result, but with a much simpler model. Peer-to-peer. Yeah. Does that answer your question?
That is partly one of the things, because mainly the Cosmos will be using mostly for building the ecosystem, which contains diversified networks, and to build some ecosystem. But I was trying to see what is the difference between that particular low-level technology.
So I presume you build on Cosmos because you want to have a universal platform?
Yes.
Yes. Okay. But underneath the hood, you still have these blockchains that the users will live on, I suppose. Yeah. So we're doing away with one element of the stack you can think of. Yeah.
Okay. Thank you.
Question here.
So in your example there, like obviously the spends are functioning on the underlying blockchain, but there's also the signature part, like you showed, is actually in the, I assumed is like at the script part of the token signature.
Yes. Yes.
Is this scriptable within like Bitcoin script, or like are you limited to the template in which the transactions of the chain can be, or are they flexible such that you can code these as well?
Okay, so the question was about, as I presented it, I just did a very simple transfer. There wasn't any multi-sig or anything like that. So I'll answer that in two parts. The new packet that we introduce, you have complete flexibility. You can add any type of scripting language you want. It could be Bitcoin script or a Solidity smart contract. It's a completely bespoke format. I've presented you a very simple one here, which just requires one signature from the sender and a public key of the receiver. But one interesting thing is you're free to choose what signature scheme you use. So you might be familiar in Bitcoin, we use SECP 256K1, and that is not compatible with popular hardware like Apple. You can't have that in a hardware module of your phone. So I can't secure my token transfer using my phone's hardware. You can here. It's authorized using secure enclave friendly signatures. So that's another advantage of the scheme. The packets are completely flexible. The underlying blockchain, at the moment, we don't use the particular scripting capabilities. We were just concerned with getting this working in the first place, but that would be a very interesting thing to explore. Perhaps I can commit to my token with a multi-sig, for example, something like that. There's no reason why you couldn't. But that will all be blockchain specific. So it's maybe, if I'm using it on BSV, I can use multi-sig, then transfer to Ethereum, maybe some other interesting way of committing to the packet. That's how you would use the blockchain scripting capability. Thank you.
Hi, Owen. Great talk, and congratulations on being a married man and on getting your USDC back. I just want to say I think it's really cool, this cross-chain token methodology, and my question is, if you know that the token is likely to circulate on some blockchains that are expensive to use, is there some way to kind of pre-fund or top up the token or at the point of creation, such that it can be transferred at least a few times on, for example, Ethereum, without the user on that network having to even own any Ethereum or other blockchains that are expensive?
Okay, so the question was around blockchains with expensive fees, and can we have a token with enough value to top up those fees? So thank you for bringing up this point, because fees are important. In this paradigm, your native blockchain token, your BSV, for example, is just used for fees. We don't ever transfer the native token from one user to another. So if I'm using it on Bitcoin, I just consume my Bitcoin in a transaction fee to write data to the chain. If you're using Ethereum, you have to provide your own Ethereum. Now, it could be very useful in the sense that I have a token issued on Ethereum where I found this out the hard way. It costs $15 for a transaction. Maybe you can send it to a cheaper chain to transfer it if you're doing some more high-frequency transfers, and then back to Ethereum. So you can suddenly start playing around with a blockchain you want to do the transfer on compared to a blockchain you might want for some other purpose. In the packets themselves, there's no reference to a blockchain currency or a blockchain fee. It's completely independent of that. So it's quite clean. You know, your packets, say you're I don't know, a central bank, and you don't want to actually have to deal with blockchain native currency. I can just issue my central bank digital currency in this packet, and it never gets mixed up with the blockchain fees that the users use to receive and transfer their token. I hope that answers the question as best I can.
Yeah, thank you very much.
Thank you. Okay,
Which one?
we have, I think, a question over here first. And I think this is the last question, so.
Which one? It's 12:15, yeah. Oh.
So just a quick question. You showed the example, and there's obviously a human element in that. So within your use case, you selected the wrong value from the drop-down. Mm-hmm. What are you doing to try and prevent that from happening when there's still a human element in this transfer process?
We've removed one point of human failure. I don't need that drop-down menu anymore if I'm transferring the same asset. It's not issued and locked into different chains. That's actually very good for liquidity, by the way. Often these cross-chain bridges are used purely for liquidity. But I think the solution to human error is better UX, and I think AI will play a role there as well. So instead of having to cut and paste complex addresses, I can just tell an assistant, hey, I'd like to send this NFT to my friend using this blockchain. But yeah, we're not reducing human error completely, but we're removing at least one trip-up point. Okay, let's leave it there. Oh, okay, one quick question at the front, because I saw how excited you were.
This is awesome, Owen. So thank you, first of all. There's a lot of things about using a single database, like checksums to make sure that the address you input is a valid address where you're trying to send it, for example. And there's lots of other reasons why you'd want to use a single database for practical reasons, but like you said, liquidity and all these other things moves around. Is there a central database where everything lives? Is that my understanding? So whether it goes from BSV to ETH or Polygon or wherever else, is there a single blockchain where everything is living, so you keep track of everything in one spot?
By design, no. And the reason for that is we want to have as many options as possible. So the only people who need to be aware of the packets are the users themselves. It's more like the history of a piece of art. You know, the only people who know the complete history is the current owner. That's how we've designed it. Of course, you could make that all public. There's nothing, now you have the option. This has very strong privacy controls, much stronger than the native blockchain, stronger privacy controls than the Bitcoin it was issued on. And using more advanced tech like zero-knowledge proofs, you can make it completely private. So I'm not, even if I receive it, I can verify it without having access to the entire history. These are typically requirements of government-level initiatives like CBDCs. And that's actually, to tell a little anecdote, that's how this came about. We weren't trying to solve the problem of blockchain interoperability. We're trying to solve the problem of token privacy. And by doing so, we realized you got this for free.
Very cool. Thank you.
You could, if you wanted to, you can put the packet information on-chain. You could do it in the same transactions that record the commitment, or you could do it all on one chain. Let's say Bitcoin. You can record all of the packets as well.
Cool.
Thank you. Okay. Okay. Oh. How do you turn on a cube? I don't know.
I think
Shake it?
It would be a really important time to tell the audience that BSV is eventually going to be a thousandth of a penny in the size of data that it processes, because if anybody in the room doesn't know,
Okay.
it's a really good time.
Well, I think Robin's point was that her favorite blockchain is BSV, mine too, because it wins on fees. You know, it costs 1,000 of a penny to send transactions on BSV. But that might not be the blockchain you use, but maybe you want to use this one to conduct transfers. Okay, thank you so much for listening, and please come and talk to me afterwards.